I made a new kind of detector which will get wireless energies from human hands over a distance of about 5 centimeters around the edge of the loop antenna or through the center. How is this possible? It seems like it goes against all the basic principles of science they teach in school. Would you like to learn more? Just watch this video and the previous ones, please, and then you'll be amazed. Was worried about Wi-Fi radiation from my neighbors affecting the results of our experiments. Wasn't contaminating my body. So what I've done is I've found this large tree on the Parramatta River, and I've set up the same experiment there with a DC battery, an inverter, and a DC power supply. I'll put my hands in and see if the light still comes on. Set up under this large tree, the LED is very faint. When I touch the loop, it clearly gets stronger, but not so strong. When I put my hand through the loop, there's very little effect. Therefore, some effect may be coming from my body, and the rest may be coming from Wi-Fi radiation in the environment. Here back in the lab, we can get a strong flashing light on the LED when a Wi-Fi extender is turned on over there. When we turn off the Wi-Fi extender at the wall, then there's no LED light. I'm literally surrounded here in the lab, even with that Wi-Fi extender turned off, by the Wi-Fi networks of my neighbors. If I put my hand through the loop, even with it off, you can see the LED lights again. Like my hand's acting as an antenna for invisible Wi-Fi energies from elsewhere. We can also extend the distance over which my hands will turn on this detector by using a small aluminum tube antenna. I hold the aluminum tube at one end, put it through the loop, and you can see the light comes on. Take it out again, it goes off. Put it in again, take it out again. So clearly some influence is going from my hand, the length of the tube, and then into the wire of the detector. A huge piece of aluminium will make the light turn on all by itself, even without my hands being attached. It's picking up Wi-Fi emissions from the networks of my neighbors. When I take this huge bar of aluminium out, the LED goes off again. You get the idea now? The human body and my hands are acting like an aluminium tube or bar as an antenna for Wi-Fi energies in the environment nearby. There aren't any Wi-Fi emitters closer than 30 or 40 meters away, but my body is acting like a huge aluminium antenna, a biological antenna, to absorb such energies and then retransmit them wirelessly to this loop antenna within the detector. From human hands will turn on that LED for a distance about 5 centimeters. Quite remarkable, isn't it? Now, in order to observe a wireless effect of human hands on this LED light, you have to place an electrolytic capacitor. I'm using 16 microfarads in parallel to the power supply coming out of, say, this supply or that supply. I was using this really big supply before and I thought I'd try another one, so I went to this little cheap supply, which is okay, but without this capacitor here to stabilize the supply voltage, I couldn't see an effect of human hands on the LED light. I'll take the capacitor out now and show you what happens. We take out the capacitor and just use two simple wires from the power supply to this circuit. Then the wireless antenna no longer works, but we can still touch the antenna over here to make the light turn on or off. However, the wireless antenna won't work. So you have to have an electrolytic capacitor to stabilize the voltage coming into the circuit to make the wireless antenna work. Next, I'm using a 12-volt DC battery to power a 600-watt inverter from DC to 240 volts AC. And then I'm going back into a DC speed controller at about 5.1 volts. And essentially I'm putting a 16 microfarad electrolytic capacitor in parallel with that power supply to stabilize the voltage coming in, which is essential. Now if we look at the LED light for wireless power of my hands, you can see the LED clearly comes on when I put my hands to the loop. This is a 2 gigahertz transistor. If I touch the wireless loop, it also turns on. Put 80 volts AC power at 50 hertz on this little variac and a switch through a 1K resistor through this loop. It won't light up the light at all, except when we flip the switch on and off. So just putting a lot of current, AC current through the loop at 50 hertz won't turn this device on. Moving a magnet or a wooden stick in and around this device likewise has no effect whatsoever on the light coming on. Whatever you do, it won't light up. When we try to measure DC voltage, AC voltage, and AC frequency from this device with the LED on or off, and we're using a transistor which works to 2 gigahertz. With the LED off, the DC voltage is 1.58. We put our hand in and it drops to about 1.46. Take our hand out, goes back to 158. The AC voltage with the LED off is only 0.1. Put our hand in, the light gets very bright. Goes way up to 0.85. Take our hand out, down to 0.12. Put our hand in again, back up to 0.9, 0.85 or so. Basic problem with characterizing these energies from human hands is that their frequencies seem very high and not easy to measure even using an oscilloscope. Here we have a Tesla coil putting out 470 kilohertz as shown in previous movies, and here's a lead from the oscilloscope some distance away. If we look at the oscilloscope screen, we can easily read 470 kilohertz out of that and see a sinusoidal waveform from the Tesla coil. When we turn the Tesla coil off, then the screen is blank and shows nothing. But when we try to read the energy from a Wi-Fi extender at 2 gigahertz on an oscilloscope, we just get garbage. This Wi-Fi extender is putting out an AC voltage of about 0.03, and the red light's on the multimeter, and here's the lead for the oscilloscope. So it might be picking up 2 gigahertz energies. We go to the screen here and we see absolutely nothing. There's just a little background frequency at 50 hertz or something, the wall power. It can't pick up 2 gigahertz energies on an oscilloscope. And this oscilloscope is rated for 100 megahertz. It still won't work. Similarly, when I try to use an oscilloscope to measure the frequency of a signal produced by human hands in this device, turn the light on, as you can see here with my hand inside, I get no reliable frequency measurement on the oscilloscope. Take out the capacitor and just use two simple wires from the power supply to this circuit. Then the wireless antenna no longer works, but we can still touch the antenna over here to make the light turn on or off.